Prior to starting the steering gear test, the first engineer will call the bridge via the sound-powered telephone seen on the left there and ensure they are ready to start the test. As the test begins here, the first engineer will begin making a round of the steering system as the bridge moves the rudder port starboard to center a total of 2 times so both hydraulic units can be tested and so the bridge can test our steering equipment. The starboard side number 2 hydraulic unit is being tested first, and the first engineer will inspect the motor and the pump to ensure they are both moving hydraulic fluid sufficiently to the hydraulic rams. Here at the number 2 unit, the first engineer is making sure the electric motor, hydraulic pump, and oil tank are operating properly and can move the hydraulic rams without any hesitation or issues. Back at the rudder post, the first engineer is inspecting the post for grease and the hydraulic rams for a thin layer of oil around them to make sure all moving components are sufficiently lubricated. As the rudder moves and begins to switch sides, the first engineer is looking for any discrepancies, such as metal shavings, sparks, or friction marks that could be an indication of a machinery issue. The temperature level and other gauges on the oil tanks should also be monitored to ensure the pumps are operating properly. Coming back round front, the first engineer is inspecting the number 1 port side hydraulic unit and ensures it will be ready to come online and be tested as he inspects the rest of the system for drips and leaks in the piping. Back round front, the first engineer is making sure that the rudder stops at 0 degrees on the physical rudder angle indicator before it turns to port and starboard again. The steering gear test offers as a method for the bridge to ensure their directional indicators are operating properly so that they do not have any steering issues while underway. The steering gear test is required under 33 CFR 164.25 and make sure that each vessel tests its steering system before arrival and departure of a port. Reaching back to 0 degrees, the number 1 port side hydraulic unit has been started up, as you can see by the moving electric motor, and the starboard side number 2 pump unit has been shut off as it has been sufficiently tested from port to starboard. As the system operates under the number 1 hydraulic unit, the rudder will be moved 30 degrees starboard to 30 degrees port and then back to 0 degrees to ensure it can sufficiently move the hydraulic rams. The rudder post on this vessel is being moved by a 4-ram wraps and slide hydraulic steering gear system. The 4 rams in this system are moved by 2 electrically driven variable delivery axial piston type pumps that are located in their individual oil tanks as seen on the port and starboard side. The system is manufactured by Tongmyung Heavy Industries and can deliver a maximum torque of 485 ton-meters and can move the rudder post to 35 degrees port all the way to 35 degrees starboard. The number 1 and 2 hydraulic pump units can be turned on and off either remotely or locally. For this test, they were turned on and off remotely from the bridge. However, they can be switched to a local control mode on the control panel and can be turned on and off from there as well. On the tail end of the test here, the rudder post is moved all the way up to 35 degrees, just up to the limit switch before it's brought back to 0 degrees. The first engineer will make a final inspection here of the entire rudder post, the hydraulic rams, the pump units, and the system overall to ensure it is ready for function while underway. Once the rudder reaches 0 degrees, the steering gear test has been concluded and the bridge will call down to confirm with the first assistant engineer. It may have been hard to hear, but the bridge called down to the first engineer on the automatic telephone and confirmed the gyroscopic heading as well as the end of the steering gear test.